Struggling with the H-index problem on LeetCode? Today, we're breaking down LeetCode 274. This is a classic interview question asked at companies like Google and Amazon that tests your ability to optimize from a sorting-based approach to a linear time solution. Let's dive in. The H-index is a metric that measures both the productivity and citation impact of a researcher. Formally, if a researcher has 5 papers with 3, 0, 6, 1, and 5 citations, their H-index is 3. Why? Because they have at least 3 papers with at least 3 citations each. The other 2 papers have fewer than 3 citations, so we can't go any higher. Our goal is to find the maximum possible value of H. Think of it like a bookshelf where you rank your papers from most cited to least cited. We want to find the point where the number of papers on the left is at least as large as the citation count of the current paper. It's like finding the largest square that fits under a citation curve. If you have 10 papers, your H-index can't be more than 10, no matter how many thousands of citations one paper might have. While sorting the citations in descending order gives us an O of n log n solution, we can do better. Since the H-index is capped at the total number of papers, let's call that n, we can use a frequency array, or bucket sort approach. We'll create an array of size n plus 1 to count how many papers have 0, 1, 2, up to n or more citations. This allows us to find the H-index in just one pass through the data and one pass through our buckets, making it a very efficient O of n solution. Let's dry run with the array 3, 0, 6, 1, 5. N is 5. First, we build our buckets. 0 citations? 1 paper. 1 citation? 1 paper. 2 citations? 0 papers. 3 citations? 1 paper. 4 citations? 0 papers. 5 or more citations? We have 2 papers, 5 and 6. So bucket 5 gets 2. Now, we iterate backwards from n. At bucket 5, we have 2 papers. Is 2 greater than or equal to 5? No. Move to bucket 4. Total papers so far is 2 plus 0, which is 2. Is 2 greater than or equal to 4? No. Move to bucket 3. Total papers is 2 plus 0 plus 1, which is 3. Is 3 greater than or equal to 3? Yes. We found it. The H-index is 3. Here's the Python implementation. We initialize the count array with size n plus 1. We iterate through citations, capping any value greater than n at n. Then, we loop backwards through the counts, keeping a running sum of papers. The first index where the total papers is greater than or equal to the index is our H-index. The time complexity is O of n because we iterate through the citations array once and the count array once. The space complexity is also O of n to store the bucket counts. This is a significant improvement over the sorting approach. If this video helped you understand the H-index logic, make sure to like and subscribe for more LeetCode deep dives. Check out the link in the description for the full code. Happy coding, and I'll see you in the next one.